Why isn't Roman concrete used today if it was so strong and has lasted for thousands of years? Roman concrete, known as opus caementitium in antiquity, is a remarkable building material developed by the Romans around the 3rd century BCE. It is renowned for its durability and longevity, primarily due to its unique composition, which includes volcanic ash, lime, and seawater. This mixture allows the concrete to withstand the test of time, as evidenced by the enduring structures such as the Pantheon and the Colosseum, which still stand today after nearly 2 millennia. In contrast, modern construction primarily relies on Portland cement, which, while effective, does not possess the same remarkable resilience or environmental benefits as its Roman counterpart. The significance of Roman concrete in the context of modern construction lies in its potential to revolutionize building practices today. Its low carbon footprint, achieved through the use of volcanic ash instead of the energy-intensive Portland cement, presents an environmentally friendly alternative that could help reduce the substantial carbon emissions associated with modern concrete production. Additionally, Roman concrete's impressive durability offers the potential for longer-lasting structures, reducing the need for frequent repairs and reconstructions. Real-world applications of exploring Roman concrete principles are already being investigated. For instance, researchers are studying ancient Roman maritime structures to better understand how the material interacts with water to increase longevity. Another example is the experimentation with volcanic ash in modern concrete mixtures to improve their sustainability and durability, taking a leaf from the Romans' book in enhancing the material's properties. Supporters of adopting Roman concrete's principles in today's construction industry argue that it could significantly decrease environmental impact while enhancing the longevity of buildings. However, there are challenges and controversies associated with this idea. One major challenge is the availability and accessibility of volcanic ash and other specific materials needed to replicate Roman concrete on a large scale. Additionally, the current construction industry is heavily reliant on modern techniques and materials, making a complete transition to Roman-style concrete both economically and logistically complex. This exploration into Roman concrete intersects with broader discussions about sustainability in construction and innovation in building materials. By examining the potential applications and benefits of Roman concrete, we can better understand how ancient wisdom might inform modern practices and address pressing issues such as climate change and resource conservation. This consideration encourages a more holistic approach to construction, balancing tradition with technological advancement to create a more sustainable built environment for the future. Roman concrete, known as opus caementitium, is an ancient building material that has intrigued modern scientists and engineers due to its remarkable durability and longevity. Unlike modern concrete, Roman concrete was made using a mix of volcanic ash, lime, calcium oxide, and seawater, which contributed to its unique chemical properties and resilience. The significance of Roman concrete in today's context lies in its potential to revolutionize modern construction techniques, particularly in creating structures that can withstand harsh environments and last for centuries. One of the most compelling examples of Roman concrete's application is the Pantheon in Rome. Constructed around 125 AD, the Pantheon's dome remains the largest unreinforced concrete dome in the world, showcasing the material's incredible strength and durability. Another example is the numerous Roman piers and breakwaters submerged in the Mediterranean Sea for over 2 millennia, largely intact despite constant exposure to salt water, an environment notorious for corroding modern concrete. Opinions on the potential revival of Roman concrete in contemporary construction are largely positive, driven by the pursuit of sustainable and long-lasting building materials. Advocates argue that adopting similar compositions could reduce the carbon footprint of modern concrete, which is a significant contributor to global CO2 emissions. The longevity and minimal maintenance required for Roman-style concrete structures would also result in economic advantages over time. However, several challenges and controversies exist around the widespread use of Roman concrete today. A major hurdle is the availability of key ingredients, such as specific types of volcanic ash, which are not as easily accessible in all parts of the world. Additionally, the traditional production process of Roman concrete does not align with the rapid pace and scale of modern construction demands, Some skeptics also question whether the environmental benefits would be as substantial when applied globally, considering potential resource extraction impacts. The exploration of Roman concrete influences discussions on sustainable building practices and materials innovation. By examining ancient techniques, researchers hope to inspire new methods that blend historical knowledge with modern technology. Understanding why Roman concrete isn't widely used today sheds light on the complexities and trade-offs involved in adopting alternative building materials. It underscores the need for a balanced approach, integrating ancient wisdom with contemporary scientific advancements to foster more sustainable construction solutions. Roman concrete, known as Opus Caementicium, was a revolutionary construction material used extensively throughout the Roman Empire. It is characterized by its remarkable durability, achieved through unique ingredients and techniques that set it apart from modern concrete. Unlike the Portland cement predominantly used today, Roman concrete employed a mixture of lime and volcanic ash, among other materials. This blend, when combined with seawater, produced chemical reactions that reinforced the structure over time, contributing to its longevity and resistance to elements. The significance of Roman concrete lies in its resilience and the marvel of engineering it represents. Structures like the Pantheon and the aqueducts, which have endured for millennia, highlight the material's exceptional ability to withstand weathering and seismic activity. Despite its ancient origins, it continues to captivate modern scientists and engineers seeking sustainable alternatives in construction. A prime example of Roman concrete's real-world application is the Roman Pantheon, whose massive dome remains the largest unreinforced concrete dome in the world. Another notable instance is the Roman seawalls and piers, some of which have persisted underwater, defying typical corrosion seen in modern equivalents. Researchers have found that the interaction between volcanic ash, lime, and salt water caused the formation of new minerals over time, self-healing cracks and strengthening the material. Several contemporary engineers and historians advocate for studying Roman concrete as a path toward developing greener building materials, noting its low carbon footprint compared to Portland cement. However, potential challenges arise from the rarity and inconsistency of high-quality volcanic ash, as well as discrepancies in ancient documentation, making its replication complex and possibly impractical on a large scale. Some alternative viewpoints argue that modern concrete, while less durable, is more versatile and cost-effective for varied construction needs. Others emphasize that the infrastructure demands and architectural preferences of today differ significantly from those of ancient Rome, necessitating different materials and methods. Understanding the historical composition and techniques of Roman concrete connects to broader discussions about sustainability and innovation in the construction industry. The exploration of ancient methods provides insights into past technologies and prompts questions about how we might adapt these lessons to address contemporary challenges. In this way, Roman concrete serves as both a historical curiosity and a potential inspiration for future advancements, fostering a dialogue between ancient practices and modern ingenuity. Roman concrete, known as Opus Caementicium, is a remarkable ancient building material that has stood the test of time, evidenced by enduring structures like the Pantheon and aqueducts. It was made with a combination of volcanic ash, lime, calcium oxide, and seawater, which reacted with the volcanic ash to form a mortar incredibly resistant to the elements. This unique composition allowed Roman concrete to become stronger over time, a property not shared by modern Portland cement. The significance of Roman concrete in relation to the main topic, why it isn't used today, lies in its durability and environmental advantages. Unlike modern cement, which contributes heavily to carbon emissions due to its manufacturing process, Roman concrete's ingredients naturally occur, potentially offering a more sustainable alternative. This distinction raises the question of whether modern construction can benefit from revisiting ancient methods to improve longevity and reduce ecological impact. A real-world illustration of Roman concrete's efficacy is the Roman Pantheon, whose dome still stands as the largest unreinforced concrete dome in the world, over 1900 years after it was built. Another example is the ancient Roman seawalls and harbor structures, which have withstood constant ocean battering for millennia, highlighting its remarkable resistance to chemical decay through a self-healing process that modern materials fail to replicate fully. Experts like Marie Jackson, a geologist who has extensively studied Roman concrete, advocate for research into its properties to inspire new sustainable building practices. Her studies have shown how the crystalline structure of Roman concrete offers insights into creating longer-lasting concrete materials. However, challenges lie in the adoption of Roman concrete. The ancient mix relies on specific volcanic ash found around the Bay of Naples, which is not easily accessible or available in similar amounts globally. Additionally, modern engineering standards and commercial practices favor the consistency and predictability provided by Portland cement, making the widespread shift to Roman methods economically and logistically challenging. Some engineers argue that modern concrete's initial strength is more reliable for today's construction needs despite its longevity issues. In exploring why Roman concrete isn't used today, it influences broader discussions on sustainability, durability, and innovation in modern construction. By understanding the benefits and limitations of ancient materials, current practices can evolve, potentially incorporating Roman techniques into future developments that seek to marry the strengths of the past with the technological advancements of today.